Yep. Next presenter is Daniel Helstrom.
Yeah. Hi, my name is Daniel Helstrom from Cobham Gaisler. Earlier this week I had a presentation about our new processor IPs and the roadmap going forward. This presentation, as part of the sponsorship, I will talk a bit about the current components processors and some announcements recently made around them and the software environment updates for those components. Yeah, that's pretty much it. So our current high-performance processor is the GR740, which is a quad-core Leon 4 machine running at 250 megahertz. We just recently announced that we are signed a contract with ESA, and together with RUAG Space we will design a new single-board computer based on the 740. It will include an FPGA and that will sit next to it, and it will be a flight model, and we will also develop boot software for it, and it will have most probably a VPX backplane. So you can read more about that on our homepage. Recently we finished our core activity we had at ESA previous 2.5 years, I think. That resulted in a single board computer that will be available next quarter, also based on 740, and it has been used together with a mezzanine board interfacing a European FPGA that is SRAM based, so it's possible to reprogram it in flight. And we also did some boot software for that one. We also, last week, we had a press release on GR740 will be available in plastic. So that's another ESA activity, also funded by other than ESA. And basically we take the 740 die as it is and put it into a plastic ball grid array. Same number of pins basically as the 740. We expect prototypes to be available after summer. Going through the 740 project, at the moment we're starting the qualification, and we plan to have a QML equivalent in Q2 and Q3, and after that we'll seek DLA approval for QML V. I'll skip those. GR716, I presented that last year, I think, at Flight Software Workshop, so I won't go into detail of that one, but it's a Leon 3, a new bus architecture, and on-chip memory. It's our new microcontroller. And then we made that available this year. So when there's development boards and prototypes available, you can find on the homepage more information about it. We are taking that into qualification, and it's expected to be available in a year. So this is basically the features of the 716 as it is today. We are currently working on an enhanced version, which will be 716B. The primary updates will be a new floating point unit that will use the floating point unit that we have in our other components, which are more, it's pipelined, so it's faster. We will double the frequency. We will have a spaceway router with 2 ports instead. There's a new IP that allows CAN-FD. There's a new Ethernet support in it, and we also increased the resolution significantly on the internal ADC. But there's also a new mode where, well, the processor will still be available for you to program, but it also features interface to SRAM-based Xilinx FPGAs. And it's a new IP that we are currently developing and testing. So you can interface it, for example, to Vertex 5 or Altuscale, and then it can be used to program the FPGA or to scrub the FPGA in runtime, so that you can use those FPGAs in space easier. And the schedule for this one goes faster than the 716 because it's based on an existing product that we already taken through the flow. We are just adding some new features to it. So we expect tape out in June and to have prototypes after the summer next year. On software, I think last year or maybe even maybe the year before that, I've been here and talking about our bootloader that we made for the JUICE satellite mission at ESA, where 7 of those instruments are using our bootloader. We have had another activity, Cora, which I just mentioned, also using that bootloader. And now the new 740 single board computer that will be reused and target flight as well. Even though there's no specific mission, it's intended to be in many different missions. So in parallel with all that development, we have internally also worked on making it a product. So GRBOOT was released a couple of months ago. You can find out more on our homepage, but the difference to the JUICE bootloader we had from the start is that now we can run it under different processor components. There's a new software architecture that allows BSP more easy, and there's the standby monitor that we had. It acted as a remote terminal over SpaceWire, so you could patch and upload new application. That's not currently available, but it will be when we're done with this. So in a half a year, that will also be available. About that bootloader, it's following the ESA Savoir flight computer initialization sequence standard, and also we have developed that using the ESSS engineering and quality standards. It's capable of initialization of the whole system, and it performs self-tests, and then it generates a boot report for the application to read later on. It is then you come to an optional, if you want to add your own standby, or later on you could plug in our SpaceWire remote terminal. Otherwise it goes directly into application loading. There's a ELF-like format that allows you to patch afterwards, and it uploads section by section to different parts of memory, if you like. And it's capable of booting all the operating systems that we support today. So the two use cases we see is just operated as an ordinary bootloader, but it has a fallback. If an image fails, then it will go to the second fallback image. But you can also use it, a bootloader, with maintenance mode. Along with that, we deliver it with test documentation and validation cases that we use our simulator to run it on. We also recently released TSIM3, which is available for beta testing for existing TSIM2 customers and GRSIM customers. It supports multi-core. That's the main feature of TSIM3. So now you can run Artem's SMP, for example, in the simulator. And if you compare this to the simulator to QEMU or SIMIX, that has also been discussed through the week, is that our simulator has a high precision multi-core model of the CPU and the bus, which allows us to model bus contention and interprocessor conflicts. Also new is we have now an SDRAM model. There's a Tickle front end, so we have tried to harmonize GRMON and the TSIM's user interface. So you will, if you're a GRMON user, you will recognize yourself much easier to get started with TSIM. And the Tickle interface allow you to integrate TSIM into various frameworks or perform validation checks of your software without writing software for it, just to do that in Tickle instead, and so on. And there's also GRBOOT support now. Well, and there's a bus trace, there's a lot of things going on. In a couple of weeks, we will also release support for the Leon 4 740. The first release will focus on the bus architecture, the L2 cache, and the memory, and the CPU itself. Not so much the I/O. And we have focused on the primary use case, where we have the 64-bit SDRAM and the default settings in the L2 cache when it comes to replacement policies and so on. And we have the wider bus width. But we also added some new IPs like GR-CAN interface, for example. But then we also plan another release in the beginning of next year, where we will add UMBUS split support. We already done part of that work in the CPU. So then we will also have a more timing accurate models that actually, even in the 740 with the HB split responses, it will be able to model that and give correct timing. And the roadmap for TSIM3, I can mention, there's a lot of things that we plan, but fault tolerance and error injection is one of them for next year. And also to configure it in 32-bit SDRAM mode. This is my last slide. There's some other updates on the software environment that I want to mention. We have worked quite much with the LLVM support throughout the last 2 years. We have had 3 different ESA activities on it, and we've invested some time ourselves, of course. So last year, I think I presented that on Flight Software Workshop, and now we have. It's not based on the master branch of LLVM, but now it's on a stable branch, version 8. So we undergone all the testing, and we also added the UT700 support this year, and some additional optimizations from when I presented last year. So we now consider that as ready for production. We compare that with GCC, and we find out that it's basically the same performance. So it's more application dependent than it is compiler dependent, which performance you get, if it's better with GCC or LLVM. We also have introduced GRBOOT support in all our tools, which means that we can get better C and C++ source level debugging. So we're now updated all our environments, both BCC and Artem's. I think we released that last week, and then VxWorks, the latest version of VxWorks 7, to include the new LLVM Clang compiler, and it's now also built using the newer dwarf format that allows us to take benefit of GRBOOT. So that's pretty much it. Thank you for listening.
Have any questions? No questions? All right. Okay. Thank you, Daniel.
If you